Well, hi all, once again, here is John, the founder of John Academy, and today I even got a mid-faith for this occasion as we are going to be covering a new Regents exam. This one is going to be the Algebra 1, August 2025 one. So first thing you need to know for this exam, you are also given a formula sheet at the end of the exam, and this one has conversions, also some formulas, quadratic equation, for sequences also. So this we can use it during the exam, no? And also something else is that the exam can be solved mostly without the calculator. It's only for 3-4 exercises that is really helpful. And going into being in an extreme case, it's only one exercise out of the whole exam you really couldn't solve without calculator, or it will be very difficult, no? That is the one that has to do with the linear regression. So all of the exercises with the calculator, we are going to see them together into one video, no? Today we are not going to use the calculator. So even if you forget the calculator the day of the exam, you should be getting a grade on the high 90s. So let's start with number 1 here. They tell us which expression is equivalent to this other one, no? Here. So here, first thing you have to notice is this is something of the form of a squared minus b squared. Is the third Newton binomial formula, no? Therefore, if a squared is 100x squared, a square root of 100x squared is gonna be 10x, no? So a is 10x. We can already discard 1 and 2, therefore. And now b squared is 16. So a was 10x and b is gonna be 4. So we can say that a plus b times a minus b has to be equal to a squared minus b squared. Therefore, we are gonna be taking option number 3 here, no? A minus b, or a minus b times a plus b, that one. Let's jump into number 2. So Josie has $2.30 in dimes and quarters. She has more dimes than quarters. Okay, 2 more dimes than quarters. Which equation can be used to determine x, the number of quarters? So x is gonna be quarters, or the number of quarters, let's say. And the number of dimes, as they tell us 2 more dimes than quarters, the number of dimes is gonna be x plus 2. And then, well, you need to know 1 quarter is worth $0.25 and 1 dime is 0.10, no? And the total has to add up 2.30. That happens in all 4 equations. So let's see, 0.25 times x, because x is the number of quarters, that happens in number 3 and 4 only, no? And 0.10 times x plus 2. Because there were more dimes than quarters. Therefore, it's going to be the third option here. Let's see now number 3. If g of x equals this function, g of minus 3 equals, okay, so this is very easy. We just have to plug it in. So g of minus 3 is going to be equal to minus 2 times. And then, as it's a negative number, very important, here we write negative 3 in brackets, a square, because the square is going to affect also the minus sign, plus 16. First, we solve following PEMDAS, the exponents, no? So minus 3 squared is just 9, and then plus 16, no? So it's going to be minus 18 plus 16, which is minus 2, no? The one here. So we got the third option. Let's jump into number 4 directly. What are the zeros of this function? This is a quadratic equation, so you could use it or you could solve it with the formula also, but the fastest thing is just to try the different values, no? So let's try, for example, 2. What happens? 2 squared minus 8 times 2 minus 20. So that's going to be 4 minus 16 minus 20, which is minus 32, which is different from 0, no? So this one didn't work. We can already discard 1 and 3. Let's try the same with minus 2. Well, minus 2 is already in both, no? But just to make sure, let's try minus 2 also. Minus 2 squared minus 8 times minus 2. Always write the brackets when you plug something into a function and it's in a negative number. And what can we see here? This is going to be 4 plus 16 minus 20. So this one works, no? So it's equal to 0. Therefore, minus 2 is a root, a 0 of this function. And now let's try 10, for example, no? So 10 squared minus 8 times 10 minus 20. This is going to be 100, 10 squared minus 80 minus 20, which becomes just 0. So 10 was good, no? And minus 10 shouldn't be, no? So it was the second option. We are already in the second page. As we can see, it's fast, no? So number 5, which point lies in the graph of this function? We have to do the same thing. This means these are the x and these are the y coordinates, no? The first number of the bracket is the x coordinate and the other is the y, no? So we could start by trying 1. So 3 times 1 squared on the x, no? Minus 1/4 times 1 plus 3. And this is gonna be 1 squared is just 1, so 3 minus 1/4 plus 3. And this is gonna be 6 minus 1/4, no? So 6 minus 1/4 is gonna be 5.75. So that didn't work because the y should have been 6.25. So this didn't work, no? Different from 6.75. And this is what we should do with all others, no? Let's try now, for example, the fourth one, no? So 3 times 2 squared minus 1/4 times 2 plus 3. So this is gonna be 3 times 9, no? No, so 3 times 4, sorry. Minus 1/4 times 2 is 1/2, so 0.5 we can write, plus 3. So this is gonna be 12 from here, plus 3 is 15. So 15 minus 0.5, no? Which is 14.5. So also didn't work. Let's go with the first one, minus 2 now. So 3 times minus 2 squared. And then we have minus 1/4 times minus 2 plus 3. So this is gonna be 4 times 3, that's gonna be 12. This is gonna be plus 0.5 and plus 3. So this one ended up being 15.5. It ended up being the first one, number 1. So now let's jump into number 6. No, we are given two functions, f of x and g of x, and they are asking for which values of x both are equal. For that, we have to write x squared equals 8x minus 15. And we need to solve this for x, no? So yeah, let's try, for example, value of 3, no? 3 squared has to be equal to 8 times 3 minus 15. And what happens? This is 9, and this is 24 minus 15, which is 9 also. So 3 is okay, no? We can already discard 2 and 4. And now we need to do the same for 5, no? So 5 squared, is it equal to 8 times 5 minus 15? This is 25. This is 40 minus 15, which is also 25. Therefore, both 3 and 5 accomplish this, no? So both is option 3 then. Let's jump into number 7 below. Which trinomial is written in standard form and has a constant term of 5? This is very easy. Constant term is the one that doesn't have any x's. So the only two options are 2 and 4, no? So we can already discard 1 and 3 because they have different constant terms, no? And then a standard form means that the coefficients are ordered from highest to lowest, no? So here, for example, the biggest coefficient the highest order, not the coefficient, the highest order in the x is 4. That should be the first one. So this one is not in standard form. The only one is 4 there, no? So both things happen there. Let's see, number 8. When solving x squared plus 6x equal to minus 8 for x, a student did this step, no? Here. So basically move the minus 8 to the left. Which property justifies this step? Associative, commutative, zero property of addition, addition property of equality. So it's gonna be the fourth option because we are adding 8 on both sides, really. What we are doing is adding 8, both left and right, no? Let's jump into number 9 now. The table below shows the input and output values of 4 different functions, okay. Which of them is a linear function? A linear function means it's like in a arithmetic series, no? We have, that the values have also the same. So here is, for example, minus 1 always, no? You see, minus 1, that's okay. Here, for example, that doesn't happen. From here is minus 5, and then is minus 3. So it's changing, no? For every change in the x, no? Here the x is becoming 1 bigger every time, but the y is changing around. So that's not linear anymore. Here you see that the x's grow, one bigger every step, and the y's go 1 down, no? At every step. So that could be linear. And what else? Here you have minus 4. No, sorry, plus 4. Then is plus 4 again. Here is always plus 4. Which there is only gonna be 1. Okay, so this one is also not linear because it grows differently between steps, no, as we can see. This one was going down, it's going down minus 1, but then grows up plus 1 here again. So here it changed the slope. So this is not linear anymore. So the correct answer is the last one because it grows plus 4 on the y's always and plus 1 on the x, no? So it's gonna be fourth option here. Number 10, what is the solution of this equation? We can solve it very fast, it's not difficult. So we bring left the minus 24x, we will be having something like this, and we take common factor x, so it's gonna be 3x minus 24. We take common factor, and what can we see? As x is here in front, and two things multiplying each other equal to 0, either the first one is 0 or the second one is 0, no? So one of the solutions is 0. We can already discard number 1. And then 3x minus 24 equal to 0. That happens when x, we first add 24, no? And then divide by 3, and that's 8. So it's gonna be number 2 here. Let's do number 11 here also. The table below shows the radioactivity level of a substance after given time t in seconds. What is the average rate of change in radioactivity over the interval from 1 to 3, no? In the time. So from 1 to 3 here, let's see what happened. We have to calculate kind of the slope. So this will be our y2, this will be our y1, this will be our x2, and this will be our x1. And then, the average rate, it will be y2 minus y1 divided by x2 minus x1. y2 was 2.5, no? Minus 10 divided by 3 minus 1. And this is gonna be just minus 7.5 divided by 2 is gonna be a negative number, and it's gonna be the second option, minus 3.75. So I think we're gonna leave it over here. This is gonna be the first video about this exam, and we will continue in the next one.